Let's look at some of these trade-offs that we have to do while building a microservices application. Basically, any application architecture has its own pros and cons. If we understand what is the right architecture we need to follow, we'll be able to design an efficient solution for the given requirements. In a similar way, microservices also have some pros and cons. We need to understand them so that we make the right decisions. Let us see some of the trade offs that we have to make. In microservices, the services are independent. That means they live on their own life. They can be alive independently of the other service. So we have discussed about how these services can become independent. But once these are independent, there are a requirement like they need to know about each other. They need to know, be able to invoke another application. I mean, this service need to invoke this service, or this service need to invoke this service. They need to know how to communicate. And since they live in their own environments, like this can be in another node, this can be in another node, they need to have a mechanism to communicate. So let's see about the independent services what we have. Cross service calls are more costly than in process function calls. What happens in a traditional code that if I have one function here, I can have another function which calls this function, right? So this can call this function. So it is in the code only. So the application logic while execution it will happen. But in a microservices, suppose this is part of another function, another software application. This is another application. I mean, a different microservices. It has to invoke this one. So obviously there is a kind of mechanism that delays rather than a code execution. So this is the cross service calls. These are always costly. You need to think about a communication, latency, and how to handle failed calls. So it can fail in invoking it, it can be down, or there can be a latency, and there can be some other issues in the communication among these two. So the important thing is how do we separate these two? So this is the existing code, for example, the monolithic code. How do we separate that? This is one microservice, this is one microservice. We need to set the boundaries. If the right boundaries are not controlled in the design phase, we'll always need to access the data through cross service calls. That means if I create a microservices application like this, and for each call I am going through all the microservices, then there is something we have to see, like why it is going through like this. So we need to design the services in such a way that the length of the call or the chain of the call is shorter. If it is too long and is always repeated, then something wrong with our architecture. We can further optimize the architecture. Okay. So what we learn from here is independent services give an advantage that they can live on their own technology stack, they can live on their own life cycle. However, we need to build a cross communication among these services. The second thing is that if we do not break these services into appropriate boundaries, we get into a situation where we'll always have to call multiple services and the chain of the calls can become longer, keeping them kind of a dependency. We'll see the next trade off that we have to make an independent deployment. Now, independent deployment will accelerate the speed of updating applications. What we mean by that is I can update more features independently. Accordingly, need to build pipelines for continuous integration and continuous deployment. What this means is this is one microservices, this is one microservices. I need to create a pipeline for this. Similarly, a pipeline for this. If there are hundreds, I may have to create so many pipelines. Maybe the pipelines can use some common functionality, but still we need to have a mechanism to push their code into the server and deploy them. Right? So the pipelines need to be built, and the number of independent services increases, the complexity of this also increases. There is more work to manage and monitor these services. Not only that, we can deploy them and maintain them, we need to monitor them. Is this up or down? Are the resources sufficient for it or not? Is this giving a response? What is the health of this? What are the metrics that it is consuming? How much CPU? How much memory? All those things like continuous integration, continuous deployment, continuous monitoring, and then the operations and tools the necessity of them also increases because of the independent deployment. Okay. We'll see some other trade-offs. Independent technical stack. Now, as we discussed in the previous article, that we have independent services and each service can have its own technology stack. Using the right technology to solve the problem is important, right? Because we will end up doing unnecessary work if the technology is not supporting our requirement. As we said, Python may be suited in some cases, Java may be suited in some cases. So we have to choose the technical stack for the service what best suits them. Similarly, if we have diverse technologies, is not good always because too many technologies can be difficult to manage. If there is a small team, the team gets overwhelmed to keep pace with this technology. So obviously, we need to have one set of expertise for this and another set of expertise for this. Maintaining two different teams is a cost, right? And also, if a single team maintaining both these technologies is again a overwhelming task. It's more expensive to learn the technology, to maintain and upgrade it, and also by making it more complicated to build services on the pipelines. So, independent technology stack also poses some difficulties in terms of maintenance, in terms of upgrading, in terms of maintaining the CI/CD pipelines. Though it gives an advantage that we can build the application which best requires the technology stack.